Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today in this session, I want to discuss about engineering materials questions in the model paper. So I have taken model paper 1 questions, and then we will discuss the questions related to these engineering materials one by one. So the topic is model paper 1 questions and answers. We have two model papers, model paper 1 and model paper 2. First we will take the model paper 1 and then we will see model paper 2. So in this, so discuss the composition of super alloys and its applications. What he has asked. So discuss the composition of super alloys. So what is the composition of super alloy? And many super alloys are there. So one by one now we will see and its applications. The super alloys are also known as high performance alloys. The other name about the super alloys is high performance alloys, are a class of materials designed to withstand extreme conditions, including high temperatures, mechanical stress, and corrosion. So, whenever it withstand the high temperatures and high mechanical stress, and similarly high corrosion, different at extreme conditions, those material is called as super alloys. So it gives high performance and it gives better lifespan of a product. And there are primarily used in applications where these demanding conditions are prevalent, such as in aerospace, power generation, and chemical processing. The composition of super alloys divided into three. One is nickel-based alloy, cobalt-based, and iron-based. So the main category based on their primary alloying element. So what is the primary alloying element in nickel-based and cobalt and iron-based? So we will discuss. So nickel-based super alloys. The primary element is nickel, providing high temperature strength and resistance to oxidation and corrosion. Next one is chromium, enhance oxidation and corrosion resistance. Cobalt adds strength and stability at high temperatures. The cobalt material gives more strength and stability at high temperature. So that's why to enhance the property, the primary element added with other metals like chromium and cobalt to get the desired properties. So next one, molybdenum and tungsten. So it increases high temperature strength. And aluminum and titanium from gamma prime, which provides excellent high temperature strength. Next, niobium and tantalum and rhenium further enhance high temperature capabilities and mechanical strength. These are the nickel-based super alloying elements. Next, cobalt-based alloys, super alloys. In this, the primary element is cobalt. The primary element known for high temperature strength and wear resistance. The chromium, it provides oxidation and corrosion resistance. Next, nickel, often added for improved high temperature strength. The tungsten, molybdenum enhance strength at elevated temperatures. Next, carbon forms carbates which improve hardness and wear resistance. So these are the cobalt based soap alloys. Cobalt is the main element, and chromium and tungsten and molybdenum and carbon is the secondary elements. Next, iron based soap alloys. So iron is a primary element, softened with significant amounts of nickel and chromium. The nickel adds high temperature strength and corrosion resistance. Chromium provides oxidation and corrosion resistance. The molybdenum and tungsten and vanadium. These three elements enhance strength. It gives enhanced strength and stability at high temperatures. So by adding these alloys, it can withstand high temperatures, it can withstand high mechanical strength, and it can withstand from high resistance to corrosion. So that's why these alloys are called high performance alloys or super alloys. Next, applications of super alloys. One is in aerospace. So used in jet engines, turbine blades, and disc. So where components must endure high temperatures and mechanical stresses. So that's why the super alloys materials are used in this aerospace sector. The combustion chamber require materials that can withstand extreme heat and pressure. Next, exhaust systems must resist oxidation and thermal fatigue. Power generation, gas turbines. In power generation sector, gas turbines similar to aerospace applications. These turbines operate at a high temperature and pressures. Steam turbines, components such as blades and vanes must withstand high thermal and mechanical loads. Similarly, in case of nuclear reactors, so structural components and fuel cladding require materials that can resist radiation damage and corrosion. Next, chemical processing, heat exchangers, pipes and valves. In heat exchangers, operate in corrosive environments and at high temperatures. The pipes and valves used in chemical plants and where resistance to corrosion and high strength are essential. Wherever required, more resistance to corrosion and also high strength is required. So there, the chemical processing method is very useful. In oil and gas industry, drilling equipment must endure abrasive and corrosive conditions. Pipelines require materials that can withstand high pressures and corrosive environments. So medical applications, implants and prosthetics, super alloys like cobalt chromium alloys are used for their biocompatibility and mechanical properties. The surgical instruments require materials that can be easily sterilized and have high wear resistance. Requires materials that can be easily sterilized and have wear resistance. So that's why used in the surgical instruments and implants and prosthetics wherever required a bone replacement and dental implantation. So in automotive industry, turbocharger components operate at high temperatures and it requires materials with excellent thermal fatigue resistance. Next question is explain the term ceramic and its composition and list out its various applications. First, need to explain the term ceramics and its composition and what are the various applications are there list out. The ceramics are commonly non-metallic, inorganic solids that are typically made from clays and other natural materials through a process of heating and subsequent cooling. So this is not a metallic, so non-metallic. They have crystalline or partly crystalline structures and are often brittle but hard. It is a brittle nature but it is hard. The properties are ceramics are the ceramics. The term ceramics definition already we have. So what do you mean? What is the ceramics material? I explain now. Next, these properties and composition we will discuss. The properties of ceramics are high hardness and strength, high melting points, good thermal and electrical installation. It gives high hardness and strength. So hardness and strength comes under mechanical properties. The melting point, thermal properties, and the material ceramics materials are having high melting point. So that's why you can use at elevated temperatures wherever required. Good thermal and electrical insulation also. Chemical inertness and brittle and prone to fracture under stress. The applications are one is in construction site. Bricks and tiles. Used in building construction for walls, roofs, and flooring due to their durability and aesthetic appeal. So the appearance. So the appearance of the ceramics also good. So due to this, the flooring and walls and roofs also use this material, ceramics. Cement and concrete, essential components in construction for making structures and buildings. Next, household appliances, so tableware and cookware. Tableware are plates, bowls, cups, and other kitchenware made from ceramics due to their hardness and ease of cleaning. The cookware items like baking dishes and cookware are made from heat resistant ceramics. So tableware items like plates and bowls and cups all are made from these ceramics. So what is the reason? Having this property, hardness, and also ease of cleaning. The heat resistant is very high, so that's why the cookware used for cookware items. In industrial, refractories used in furnaces, kilns, reactors due to their ability to withstand high temperatures. The abrasives, materials like silicon carbide and aluminum oxide are used as abrasives for cutting, grinding, and polishing. These are the materials used as abrasives. Abrasive material for grinding and cutting and polishing. In medical field, dental implants, bone substitutes, Ceramics like zirconia are used for dental implants due to their biocompatibility and strength. And then bone substitutes used in orthopedic applications for bone repair and replacement. Electronics, capacitors, and insulators. Ceramic capacitors are used in electronic circuits for their excellent electrical insulation properties. Insulators used in electrical power lines and other electrical applications due to their high resistance to electricity. Next, aerospace. Thermal barrier coatings. Ceramics are used to coat engine components and protect them from high temperatures. The structural components, high strength ceramics are used in various structural components of a spacecraft and aircraft. Art and decoration, poetry and sculptures. Pottery and sculptures items, making decorative items and poetry and sculptures use these ceramics. So that's why ceramics are widely used in this art and decoration. So next one is explain the composition of polymers and list out the applications in detail. So what is this polymer? Polymers are large molecules composed of repeating structural units, monomers, connected by covalent or chemical bonding. They can be natural, like cellulose and proteins, or synthetic, like polyethylene, nylon. Polymers exhibit a wide range of properties. All these are polymers and can be engineered to meet specific needs. So these large molecules composed of repeating molecule monomers connected by covalent chemical bonds. Properties of polymers. What are the important polymers properties? One is lightweight. Polymers generally have low density, making them lightweight, and corrosion resistance. They resist corrosion and degradation by chemicals, making them durable in various environments. Flexibility. Many polymers are flexible, which allows them to be molded into different shapes and forms. Next, thermal and electrical insulations. Polymers often have low thermal and electrical conductivity, making them good insulators. Varied mechanical properties. Depending on the polymer, they can range from very soft and rubbery to very hard and rigid. So, depending upon the polymer, they can range from very soft and rubbery to very hard and rigid material. Next, applications of polymers are: one is packaging in construction field. In packaging, plastic bags and wrappers. It's already used for packing food, clothing, and other consumer goods. So, bottles and containers used for beverages, cleaning products, and other liquids due to their lightweight and durability. Construction, pipes and fittings. PVC and other polymer pipes are used in plumbing and electrical conduits due to their resistance to corrosion. Insulation materials, polystyrene and polyurethane forms are used for thermal insulation in buildings. Next, electronics, insulating materials. Polymers like polyethylene and Teflon are used for insulating wires and cables. Flexible circuits used in flexible electronic devices and variable technology. So in automotive field, body parts and interiors are used to make car bumpers, and for these body parts and interior polymers are used, and also used for dashboards and interior panels due to their lightweight and impact resistance. Fuel systems. Polymers like nylon are used in fuel lines and tanks. Consumer goods, toys and household items like toys, kitchenwares, and furniture are made from polymers. Supporting goods. Polymers are used in equipment like tennis rackets, helmets, and protective gear. Agriculture, greenhouse films, irrigation systems. Polymers like polyethylene are used to create greenhouse coverings. Irrigation system, the polymers are used in drip irrigation tubes and systems. So why? Because these polymer materials are very durable. So these are the references taken for this question. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.